Okay, everybody, we're back for section 3.3. I'm probably going to break this into two parts. 3.3 is going to be a continuation of what I did in 3.2. Matter of fact, I'm going to start off with the same example. There's a theorem that's in your book. I'm going to come back to that in a second. Let's go back to the problem that we had. I got it written out there. And then down here were my inequalities. These were my intercepts and my profit function. And that's the same thing I had on this page. That's kind of where I left off before. Okay, I'm going to stay with this sheet a second because this picture is a little bit better, that's why. But we did all of this so we could find our polygonal region or feasibility area, whatever you want to call it. And what I want you to notice is you've got 5 vertices. Call them corners if you want to. I need to know what the coordinates of each of those are. So I know this one is 0, 0. And I can tell this one, since that hits at 16, I know that's 16, comma 0. Notice I don't need this one out here because that's not a corner of my area, but I'm going to need this one. And right now I don't know what it is. I can guess. I bet it looks like it's about 14, maybe 4. I don't know. I need to find this one. So these two I don't know yet. And then this guy, since that hits on the y-axis at 12, I know that one is 0, 12. So one of the things that you'll be asked are, what are the vertices? So far we have 0, 0. We got 16, 0. We've got this one, but I don't know what it is yet. We've got this one. I don't know what that one is yet. And we got this one, which we know is 0, 12. So if I would ever ask you the vertices, that's what I'm asking for. Just the coordinates. Okay. So let's say we want to find this one. I don't know what that is yet. Here's what I want you to notice. This point is on this line. That's L1. It's also on this line, L2. It is not on L3. That's way up here. So this is the intersection of L1 and L2. Okay, so bear with me. What I want to do, I'm going to scrap sheet of paper. I said L1 and L2. I know L1 is 6x plus 3y, and I'm going to put 96 because I'm really talking about the line at this point. I want to know where the lines intersect. And L2, I've got x plus y equals 18. So I want to find the intersection of those lines. Now, you can do several different things. When you look at the book, they'll take and they'll solve each of those for y and put them in slope-intercept form. And then they solve them from there, and that's fine if you like to do that. I like to keep it in this form, so when I graph it, I can easily come up with the intercepts and then come up with a graph. Okay, so let's say I want to solve this, and I'm going to use linear combination. I'll keep the top one the same, and I'll multiply the bottom one by 3. So your top is going to stay 6x plus 3y equals 96. And the bottom, I'm going to multiply 3 times x, so that's 3x, plus 3 times y equals, and 3 times 18 is 54. So when I subtract those, 6x minus 3x is 3x. The 3 y's drop out, and 96 minus 54 is 42. That tells you that x is equal to 14. If I go back to this equation, I put 14 in for x. I'm going to have 14 plus y equals 18. So y is equal to 4. So my coordinate is 14, comma 4. That means when I go back, this point right in here is 14, comma 4, and that is that vertex right there. So again, what I did on that was on L2 and L1. So I went off to the side over here, and I wrote L1 and L2 down. And then I used linear combination to solve. I got x equal 14. I plugged it back in, y was 4. So that was the point 14, comma 4. Okay, back to my picture. Now I want to get this guy here. I don't know what it is. I need to separate that. Looks like I'm calling that one 0, 12 when I'm not. Okay, so this point, what two lines intersect? Well, this one right here, what is that? That's L2. And this line right here, which is L3. So L2 and L3. So I come back over here. L2, L3. L2, when I copy it from my other sheet, I'm doing 6x plus 3y. Nope, I'm sorry, that's L1. Okay. L2 is going to be x plus y equals 18. And L3, 2x plus 6y equals 72. Okay, so I got to eliminate one of them. I think I'm going to eliminate the x's on this because all I have to do is multiply by 2 up here. Keeps my number simple. So 2 times x is 2x, 2 times y is 2y, and 2 times 18 is 36. The bottom stays the same, so I'm simply copying 2x plus 6y equals 72. And when I subtract, the x's drop out. 2 minus 6, that's negative 4. Y equals 36 minus 72 is negative 36. So it looks like y is equal to 9. And if I went back over here and substitute in that, I'm going to have x. I'll put 9 in for y equals 18. So it looks like x is 9 also. So the point would be 9, comma 9. So when I come back over here, that's 9, 9, and that's this one right here. Okay, that's the hard part. Now, if you remember, I had a profit function. I know I'm switching back and forth all these sheets. My profit function was 80x plus 70y. 80x plus 70y. So the profit at 0, 0. That means I'm going to put 0 for x, 0 for y. That's going to be 80 times 0 plus 70 times 0, and that's going to be 0. Makes sense. If you don't produce either one of them, then it's going to go to 0. Okay, that was the first one. Let's go to the second one. So the profit at 16, 0 would be 80 times 16 plus 70 times 0. Should be 1, 4, 8, 0. Numbers are getting big. Okay, and going down, if you'll let me, I'm going to switch pens. This is starting to jumbling together. Where'd my other one go? There it is. So on this one, I hope this one is okay. So I'm going to find the profit at 14, comma 4, Be easier for you to see. So that's 80 times 14 plus 70 times 4. Okay, and I'm going to get my calculator out here real quick, and I'll do that. So 80 times 14 plus 70 times 4, and I got an answer of 1400. Now I'm going to go to the next one. So the profit at 99 is 80 times 9 plus 70 times 9. And that's 1,350. And then the last one here, I want to find the profit at 0.12. So I'm going to take 80 times 0 plus 70 times 12, and that's going to be 840. Do that one in your head. Okay, so I know I'm switching sheets again. I'm going to try to keep this a little neater. Okay, so here it is. So I found the profit at 0, 0 to be 0. The profit at 16, 0 to be 1,480. I found the profit at 14, 4 to be 1,400. I found the profit at 9, 9 to be 1,350. And the profit at 0.12 to be 840. All I did was copy the information. Okay, so now let's go back up here. Let's look at that theorem. I told you we'd come back and look at it. The fundamental theorem of linear programming. The maximum or minimum value of the objective function is achieved at one of the vertices of the feasibility set. Okay, let's put it in terms that you know. The feasibility set is the polygonal region that's shaded in here. So if this problem, and if you remember we wanted a maximum, the maximum would be achieved at one of the corners or vertices there. So what I did, I plugged each of the vertices into that profit function. All I need to do now is to look at those 5 numbers and say which one is the biggest. 1480, my maximum profit equals, and this is dollars, $1,480. And then you probably need to put this down, because the original problem said how many chairs and how many sofas do you need to sell to achieve that profit? Well, that means 1480 was 16.0. What does that mean? That means 16 chairs and no sofas. Now, if you're running a business, you need to know what the maximum is. There are businesses that actually hire people to do this type of mathematics, and then that generates what they make. So now you're qualified for a new job. You know how to do it. Now, unfortunately, it gets a little tougher because I only did it with 2 products, sofas and chairs. you start doing more products, the math gets messier. You could have 3, 4, 5 products or even more. And you might even say, looking at this one, you said, well, we got a maximum profit. We did 16 chairs and 0 sofas. Why even mess around with sofas? Well, next month it might change. There might be a demand for sofas that we didn't have this time around. Or maybe the profit will go up for sofas. So that changes your equations. Okay, so in a review of what we just did, so we started out in the last section with this problem. And in the last section, we came up with the inequalities by making your table. We came up with the intercept so we could graph it, and we had a profit function. Once we had it graphed, we stopped last section. This section, I'm saying we need to find each of the vertices. That's what these are. Find the profits, and decide which one's the biggest, 1480. And where does that happen? At the point 16, 0. So 16 comma 0 means 16 chairs and 0 sofas. Okay, now I'm going to stop there. That ends part 1 of lesson 3.3. And when I come back, I'm going to start with another problem, and I'm going to work it all the way through.